Questions. Functions worksheet for question number 1. I'll read out the question, then we'll explain how to do. Find the domain of the function f of x equal to x square plus 3x plus 5 over 5x square minus 5x plus 4. Okay. So we have to find the domain of this function f of x, which is equal to x square plus 3x plus 5 divided by x square minus 5x plus 4. So we know what a domain is. Domain is what all the values that x can have which will satisfy this function. So looking at this function, we see it is in the p by q format. So we see it's a rational function, and we know what a rational function is. A rational function is where p and q are both functions and q function is not equal to 0. So we have to find all the values of x where this cannot be equal to 0. So we cannot have denominator as 0. Rest any value we can accept, because we can accept any of the values in the numerator, since even if numerator is 0, it's not a problem, but we cannot have denominator as 0. So we have to succumb to this condition. So if we solve this, we can solve this by splitting the middle term. We know sum is minus 5 and product is 4. So what are the two numbers that make that? It will be minus 1 and minus 4. So you can split this like x square minus x minus 4x plus 4 not equal to 0. We can group these, taking x from these two terms, x minus 1, and we can take minus 4 from these two terms, x minus 1 not equal to 0. If we take it common, x minus 1 into x minus 4 would not be equal to 0. That means x would not be equal to 1 or 4. So x cannot be the values 1 or 4. So we can see that x would belong to, x is part of real numbers minus the numbers 1 and 4. Since giving 1 and 4 will make the denominator 0, which is not possible. So the domain would be R minus set 1 4. That would be the answer. Second question. If f of x equal to x square, find f of 1.1 minus f of 1 over 1.1 minus 1. Okay, so we have to evaluate expression given that f of x is equal to x square. Okay, and we have to evaluate the expression f of 1.1 minus f of 1 is divided by 1.1 minus 1. Okay, so if we put 1.1 into this function here, we can get the value of this function, and if we put 1 here, we can get the value of this function. So let's do that. F of 1.1, I'll do it to the side here. F of 1.1 is equal to 1.1 square by the definition of the function x square. So if x is 1.1, it will be in x square, which is 1.1 square, which is equal to 1.21. F of 1 would be 1 square, which is equal to 1. So the answer would be, so f of 1.1 is 1.21, f of 1 is 1 divided by 1.1 minus 1. Now we just calculate 1.21 minus 1 is 0.21 and 1.1 minus 1 is 0.1. Solving that, we'll get 2.1 as the final answer. Okay, so that was that. It was pretty simple. We just had to find the values of the function f of 1.1 and f of 1 and simplify the answer. Third question. Find the domain and the range of the real function f defined by f of x is equal to mod x minus 1. Okay, so now we have the modulus operator, mod x minus 1. So whenever we come across the mod operator, we should first ask ourselves what the actual, this is a variation of the modulus function. We can write the standard function as this: mod fx is equal to x if x is greater than or equal to 0, and minus x if x is less than 0. Okay, so the absolute value function has two conditions but gives only one output. So in this case we have x minus 1. So how would we rewrite our function? Our function would be mod x minus 1, same thing, x minus 1 if x minus 1 was greater than or equal to 0, and negative of x minus 1 if x was less than 0. So you can see what I did. Instead of x, I wrote x minus 1 in all the places where x would have been. So instead of x, I wrote x minus 1 here also in the conditions, minus, we make sure to not forget the brackets. And if we simplify this, x minus 1, if we bring this minus 1 to this side of the inequality, we'll get x greater than or equal to 1. And if we open this bracket, we can write 1 minus x, and x, oh I forgot the minus 1 here, and x less than 1. Okay, so if x is greater than or equal to 1, we give x minus 1 for the function f of x, and 1 minus x if x is less than 1. So this is our new function. We can write it here: x minus 1 if x is greater than or equal to 1, and 1 minus x if x is less than 1. So that is our working column. First think of the standard modulus function and rewrite everything to the terms of our question. So wherever x is there, we just place our x minus 1 or the question you have at hand, and then simplify it. So this is our question. Now we have to find the domain and range of this piecewise function. So we know the domain of a mod function is R. The standard mod function domain is R. So in every modulus function, every modulus function which is not a denominator, we can give domain as R, because even if we give any value to x, we'll get an output. So it is valid for any of these real numbers. So hence domain of our question x minus 1 is also R, or negative infinity to infinity. We can represent it both ways, R or negative infinity to infinity. Okay, so domain is done. Now we need the range. So if this function can accept any values from negative infinity to infinity, it must have a range of values which it gives as output. So what's the least value this can give as output? It's not negative infinity and it's not negative. Mod function only gives positive numbers. So what's the least number that it can give as output? It would be 0, right? Because nothing is positive to the left side of 0. So 0 would be the least positive integer that the mod function can return. So we can assign this mod x minus 1 to 0, stating that 0 would be the least value of its output. So if we consider, while solving equations, we have to consider mod of function as plus or minus symbol, and we have two options. We can give it plus and we have to solve this. If we give it minus, we have to solve this. In both the equations, we get x is equal to 1. So here in x is equal to 1, we get our lowest output was 0. So 0 would be our least output. So range would be range is the range of outputs. So from 0 to infinity would be our range. And I made a mistake here. This was supposed to be open bracket, since 0 is included in the range. We can have 0 as an output, but infinity we cannot have as output. So we put a open symbol for infinity or negative infinity. So range is from closed interval 0 to open interval infinity, and domain is from negative infinity to infinity, which means all the real numbers. Here only the positive real numbers.